Hey, Alex here again. Sorry about the junky handheld shaky cam video. This is just something I wanted to put up quick because after I did the first part of the rearm video, I had a whole lot of questions about people asking me about hooking up Trinamic and SPI with graphical LCDs and the RAMPS 1.6 Plus and that type of thing. And I'm going to be doing a RAMPS 1.6 Plus video, as well as the second part of the rearm video that's going to have more like technical details and things like that. But the RAMPS 1.6 Plus rearm video and LCD is going to be like way down the line. So in order to not leave those people hanging for as long as it takes for me to get all the research done, those 3 videos done, and all the intermediate videos, I'm going to put this little like teaser supplemental spoiler video out here about a setup for the RAMPS 1.6 Plus with graphical LCD and SD card support and Trinamic's TMC2130s in SPI control mode that works. At least it does in like the preliminary test. I don't know if it works under all conditions and things like that. I'll go into this in much greater detail in a couple other videos, but like I said, I just want to get this one out there so that if people are hanging onto the equipment right now, they're not, you know, left out in the cold until I get those out. So anyway, here we go. And as always, I'll put a time index in the video description below so you can skip around to the relevant parts or rewatch them as needed. Now again, this is not a complete review. This is just a video that is a benefit for people who are specifically running a setup of a Panikit rearm board with Marlin 2.0 in conjunction with Trinamic TMC2130 chips and a RepRap discount full graphics smart controller on the RAMPS 1.6 Plus board with SPI Smart Control. Now, if you recall, I did a review of the RAMPS 1.6, and I came down on them pretty hard for not being open source compliant. They are now open source compliant. So that's kind of renewed my interest in pursuing them as like a viable RAMPS alternative to the 1.4. Since the 1.6 Plus is basically the 1.6 with a couple extra bells and whistles, they haven't released the design files yet. I'm doing all this in good faith that they will. And regardless, there's a butt ton of setup info on the Bigtreetech website. And even good old Yosef doesn't drop his design files on release day, so we'll cut them a little bit of slack. Quick explanation of the RAMPS 1.6 Plus. It's basically the RAMPS 1.6, but with onboard capacity for running Trinamic's TMC2130s, specifically the 2130s that are meant to go with this board, which are, as you can see in this picture, mounted upside down, as in the chip package is facing up instead of facing down, which is not great for heat sinking, but it is convenient for the wiring since that's all on board, as in etched into the board pattern, and you don't have to run jumpers, but you can, as you can see from the pins that are sticking up there. And that's toggled on or off between like the Trinamic drivers or regular drivers by a couple resistors here on the board and this more elaborate system of jumpers underneath the driver chips. Now, I got the Bigtreetech drivers directly from them, and I got the full-on kit, so it's the DIY kit with the double-side pins and the jumper cables and the whole shebang. So here you can see the Vatarat chip, the MKS chip, and the Physedic chip, as well as one of the diode protector boards. This is actually a clone diode protector board. And you can get those really, really cheap these days, so there's really no excuse not to have them around. And just a note on these diode protector boards, they won't sit against each other flush on a RAMPS unless you grind the side off a little bit. I just use some sandpaper to shave off just the little jagged edges, and they work fine. And as a side note, because of the potential cooling issues, I just treated this like an A4988, and I did a little riser action with the diode protector boards and put a heatsink on the top and on the bottom, just for safe measure. Okay, no more background info, let's just talk about the problem. The 1.6 Plus was designed to sandwich on top of an Arduino Mega, not the rearm that uses a 32-bit LPC1768 chip. The problem it solves is having to solder additional jumpers on top of your smart adapter board in order to run the SPI mode for the TMC2130s. I did a video about that. But these silly panels that virtually everybody uses that are based on the ST7920 present some unique problems just because of some ways that they misbehave that I'll get into in the future. And as a result, Marlin had to put some kind of software kludges into here to make sure that everything was working. But basically, because of some peculiarities of the chip and the way that the timings work, if you don't have it set up just right and on the right hardware configuration, you just get all kinds of garbage up on the screen when you have something else on the SPI bus. This problem is not unique to Marlin or 3D printers or even to the RepRap Discount Smart Controller. This issue goes way back, like a decade and a half or so, and I and many other people have wrestled with it and solved it in various ways over the years. So that's partially why the holdup for the review video. I'm going to try to roll some of those fixes into Marlin and see how that works out. But that's going to require an oscilloscope, a logic probe, a lot of delving into the C++, and possibly some hardware modifications if all else fails. And bear in mind, there are other displays at work, like Panic Its Own Wiki panel. I haven't tried like the I2C character stuff, but if that doesn't work, I'll make sure to get it working. But regardless, if the issue is just with the RepRap Discount Smart Full Graphics adapter and control board, that means anything on that SPI bus is going to be goofy. So better to get that nailed down than to just patch this one particular problem and play, whack-a-mole. So there are three parts of this problem. First off, Trinamic2130s plus RepRap Discount Graphical LCD equals no hardware SPI because of this block that Marlin has put in the sanity check file for the HAL for the LPC 1768. Part 2 is that RAMPS 1.6 hardwires the SPI pins, the MISO, the MOSI, and the SCK, to the hardware pins that are shared by the smart adapter's LCD and the SD card on that aux header. Meaning any protocol we use on those pins has to be able to be used by all three of those different devices, or at least two of them. And the third part of it is that the RAMPS 1.6 Plus also hardwires the cable select pins for the Trinamic drivers to pins that don't exist on the rearm, or they exist but they're not hooked up to the microcontroller in any part. Because of the pin economy of that new processor, we lose 3 of the 4 of those pins. Namely 40, 42, and 45 using the Mega Digital pin designations. That's led sellers of this board to just say, hey, if you're using 2130s with the rearm, you can only use them in, dumb mode and standalone mode because it doesn't support the SPI model. But they're already selling like complete clone setups with the 2130 DIY driver chips, which is going to leave more and more people saying, but why? So until there's a fix to this, we just gotta kind of get a little bit clever with it. So here's what you're gonna do, and I'm gonna show you how I done it. We are going to run everything in software SPI off of the same pins. And those pins we're gonna use are the hardware SPI pins, and then we're going to reroute the cable select pins from our drivers. Now, is this wrong? Well, probably, and we do get a little bit of a goofiness, and I'll tell you about that, but it works for now, and that's better than, not working for now. Now, you don't have to use MakerBase's drivers. You can just use regular old 2130s and then run them just like this in the standard flying leads SPI mode if you don't mind the whole spaghetti mess. I did that, set it up as you normally would Trinamics, and that worked just fine too. But if you already bought the bundle with the MakerBase Trinamic drivers, then you can get away with as few as just 3 flying leads. But yeah, either way's fine. And mind you, I haven't yet stress tested these particular drivers, so it's very possible that because of the way that the heatsink is on the other side, they could just, overheat and be useless, so caveat emptor. So let me walk you through this. First thing is you're going to set up your printer's firmware just like you would for any other Trinamic 2130 setup. And I'm not going to walk you through that here because it would take like 10 minutes and it's been beaten to death on the internet, so you can find another source. Second thing, after you have all that done, is modify your SPI pin setup in your pins ramps rearm header file. And you're going to make it look like this. These pins should already be set up like this, but just in case, make sure that all of your defined CS pins look like they do in this picture. There will be one for each driver, and then we're going to go down to the bottom where it says software SPI pins, and we're going to change those designations. The default is to have them set up on the Ethernet header, but we are going to change them to the same designations as the hardware SPI pins because Marlin is automatically shift us to software SPI, and we don't have to worry about hogging up the hardware SPI there. Now, like I griped about in part 1 of the rearm review, there's no continuity between these pin designations from various sources, so here's kind of a matrix that I did to show you what physical pins correspond to what different names they might be, but I'll show you the actual cabling in picture form, so you don't have to worry about that. So after we change the pin's header file, that's going to assign all of the SPI to the same pins on our smart adapter. Because remember, that's where the RAMPS 1.6 Plus has our pins hardwired. Now you might be thinking, whoa, can you just do that? Well, you kinda can, and I'll get to that. Step 3. Now, remember those jumpers that we have on our board? This is where they come into play. We're gonna yank all the jumpers under the drivers that apply to the cable select pins. That means of the 4 jumpers, you pull this one, the second one up from the red headers. Now, everything but the X-axis, those pins aren't hooked up to anything, so you could leave those, but you might as well yank them. And you could also just leave the X there and reassign the pin in firmware, but it's easiest to just do it this way. Pull them all, jumper them all. Step 4 is to then run all of our new cable select pin connections, and we're just going to use female to DuPont cables for that. And the pin we're going to be jumping is the one marked CS on the board. It's this one that's marked with a silver Sharpie. And because these aren't marked on the top, I keep a burnt out 2130 around just so I can reference the pin numbers when I need it. And then you're going to land the other side of the cables like this on the J12 header, the Ethernet header. Now that first header that's turned 90 degrees away from the others and has the gray cable on it, that's your 5-volt connector for your LCD screen. So you're not going to use that for cable select, obviously, but you will use the next 4, and they're wired up like this, as in XYZ extruder. And just as a note, I use the onboard SD card, not the one that is on the panel. I didn't try it the other way around. You could give it a go. I imagine you might get a little bit extra corruption on the screen, or it might not work at all. I'm not sure, but I know at least the one on the board works. Now, speaking of corruption, everything worked fine except I got a little bit of but I ran a couple prints off the SD and off USB, and it didn't get any worse than that. So to show you that it works, here is just my little ghetto test bed printer running through a couple different test moves that I put into a G-code just to make sure that everything was working. Everything's fine. I'm not extruding any filament here, but the extruder is running and it's heated up. And yeah, I did this and a couple actual prints, and no problems, except for the blurgada corruption a little bit. And it is possible that that could be fixed in the firmware, but again, this is just a quick fix for you guys that already have those boards, and I haven't run through all the possible combinations of these things yet, so hopefully I'll have a better solution. If not, maybe I'll look into getting those lines cleaned up. And as you can see here in Pronterface, everything's working fine. It even picked up on me accidentally knocking one of the cables out. Oops. Now, obviously, it's not meant to run all of these different devices off of software SPI on the hardware SPI pins using 3 or more different libraries that are simultaneously using them, but it seems to be working, so no guarantees, but hey, at least it's something for now. Thanks, and sorry again about the substandard audio and video quality. I'll be getting those other videos out soon. I'm doing testing, like I said, these last 3 days, that's all I've done, and 2 of those I didn't sleep, so it's a lot of tests going on. But regardless, I hope that helps you out. If you have any further questions that are not too technically in-depth or things that I just may not have gotten to yet, leave them in the comments below. The answer might be, I'm still working on it, or that's something I've tested and haven't hammered out the details, but, you know, I'll try to get back to you if I can. Make sure to check out my support links in the video description below, and until the next video comes out, get out there and make something awesome.